Let's take a look at a few of the great enhancements in SOLIDWORKS simulation in 2014. Anyone who's worked with fasteners before realizes it can take quite a bit of time to set those up in simulation. This is a thing of the past in 2014, where we now can automatically detect Toolbox fasteners and map those across to simulation connectors. It's a very quick process and saves a huge amount of time in the setup of a model, but more importantly, it also ensures you have accurate information about the connector, such as the size of the fastener, the type, materials, strength data, and even the preload requirements. So that's a great improvement that we have in 2014. We've also made some great improvements in the interface to make it a lot more efficient to interact with the model and to make changes. Now through the legend, you can right click and select different stress components. Maybe you want to look at principal stresses or change it to different result type. So you can see we've got quite a lot of detail here on what we can view. We can even animate the model from this position. Also, if we want to modify any of the settings, we now have all of our options in one property manager. So we can adjust the definition, any of the chart settings such as showing the max value, or the settings where we might want to show the mesh on the model and so on. So everything really is at your fingertips. It's also very easy to come in here and quickly adjust the scale of the legend to suit whatever needs you have. So it's much more convenient than previously. We also have some great enhancements in 2D simplification. One of the things we've added is improved ability to look at contact situations, and one of the common results people look for is the contact pressure. This is now supported in 2D simplification as either a plot or as vectors, which really enhances our ability to understand where the load transfer is occurring and gain greater insight into what if we need to make changes. Now, something else that's been improved in 2014 is our ability to apply materials. We now have a connectivity to the materiality website, which enables us to access a much more wider section of advanced material properties. When the site comes up, all you do is specify the type of study you're interested in. In this case, I'm going to do a nonlinear. So we pick the material model that we're interested in, such as plasticity, von Mises, or hyperelastic. Then we choose whether we want a subclass of materials, and then any further subclasses. So for example, maybe we're interested in plastics, select locate materials, and the materiality will come back with a very extensive list of material properties. Tooltips give us more information about these, but if we want, we can pick particular items, for example Delrin, and then it will bring up the different results. For example, here we have different thermal result properties. When we do the start conversion, it will then extract the data into an appropriate format for us. We can even look at the data visually, so we can see here the stress strain curve. And all we have to do is select download, and then we'll save it to a SOLIDWORKS material file, which we can then link in, or if we put it in our library, so that we can access it through our environment here. So we've got a lot more powerful material properties available now for advanced materials in nonlinear realm primarily, but it saves you having to go and research that yourself. We also have some great enhancements on the contacts visualization front. When you select on the connectors branch now, we have a new contact visualization plot, which is a powerful tool for helping us review our model to determine how we've set it up. And different contact types will actually come back in different colors. So red is for bonded. You can even pick specific bodies that you want to check contacts between as well. In this instance, we can clearly see that there's no contact defined between the vertical face on this side wall and the back face. So this is a great debugging tool to help us identify problems, as well as to see what we've already done and what else has to be set up for the model. Another area that we've improved is with visualization of results for symmetric models. Here we have a symmetry plane for this model, and if we just hide the symbols, when we do the edit definition now, under advanced options we can now display symmetric results, which helps for conveying result information to other people in the company that may not be as familiar with simulation, and where if they see only a portion of it, it's a bit harder for them to interpret the results. So that's a very powerful tool. But there's also another very valuable tool for reviewing results, and that is the new compare results capability, which includes support now for comparing across configurations. The interface is very similar to what it was before, but now it will actually load each individual configuration, enable us to quickly look in and review the results on those designs to help us again zero in on which design we want to focus on to further develop as we progress with our design cycle. So some very powerful capabilities in Solidworks simulation. We've also got some enhancements for performance. In the simulation settings now, you can control when results get loaded. So if you are working on a lot of Solidworks features, you can now turn off loading simulation results when the model is open to delay that extra overhead. So this means that you can have simulation active and it won't cause overhead when you're working on Solidworks operations. Another great feature that we've added for people who work with very large model designs is there's a new large problem direct sparse solver. This solver is tailored to models that are dealing with millions of degrees of freedom. If it's set to automatic, Solidworks simulation will automatically determine which solver it needs to use for you, so you don't have to worry about it. One other benefit of the large problem direct sparse solver is that it has very good support for multi-core, and so not only can it solve very large problems in terms of 5 million, 10 million degrees of freedom, it can also do it a lot quicker than previously because of the multi-core support. So a lot of great capabilities there that we've seen in Solidworks simulation.